Welcome to the class. We started module 4 and discussed correlation and rank correlation in our last lecture. Before going to next subtopic, let me just recall what we learned under this setting. And we will take a clue from this one to start our next subtopic. See, this is what we learned there. If n values of x and n values of y are given, then is it possible to identify to what extent these two variables x and y are correlated? Is there a linear connection between the two variables x and y? Which means where we actually learned whether we can fit this data to the straight line or not. So today's subtopic speaks on this, that is lines of regression. Let us see the definition of this. This is what it says. If we can establish the linear correlation between the two variables x and y, then the line of best fit which we can obtain from this data is called the line of regression. In fact, two regression lines are possible for the data depending on our expectation, whether we wish to estimate the value of y or the value of x. The line of best fit which is used to estimate the value of y is given by y minus y bar equal to r sigma y by sigma x into x minus x bar. This equation can be derived by using the method of least squares. And the equation which gives the best possible value of x can be obtained by replacing each occurrence of x and y by y and x respectively. That is, x minus x bar equal to r sigma x by sigma y times y minus y bar. And this equation is called line of regression of y on x. And this equation is called line of regression of x on y. Okay, let me repeat. This equation, that is the line of regression of y on x, is used to estimate the best possible value of y for each specified value of x. And this equation, that is line of regression of x on y, is used to estimate the best possible value of x for each specified value of y. Observe these two equations carefully. These two are made up of same two variables x and y, and the same numerical constants are sigma x, sigma y, x bar and y bar. And we know x bar and y bar represents mean values of x and y respectively. Sigma x and sigma y are the standard deviations of x and y respectively, and r is the correlation coefficient given by sigma xy divided by sigma x into sigma y, where sigma xy is the covariance between the two variables x and y. That is, under the previous subtopic correlation, we learnt how to find the value of this r. So finding the lines of regression becomes just the continuation of whatever we learnt in our last subtopic. That is, find the value of r from this formula and substitute this r along with sigma x, sigma y, x bar and y bar in these two equations to have regression lines for the given data. Have a look at this expression in my first equation. It is called regression coefficient of y on x, and let me denote it as myx. That is, myx is equal to what? R sigma y by sigma x, and is called regression coefficient of y on x. In the same lines, this expression is called a regression coefficient of x on y, and we denote this as mxy. Next, let me discuss slope of these two straight lines. We know if we consider the straight line y equal to mx plus b, then the constant m, it is the coefficient of x, is the slope. So if that is the case, you can note for this equation, the coefficient of x is r sigma y by sigma x. This becomes slope for this straight line. Whereas for this straight line, the coefficient of x is found by taking this to the left hand side, that is 1 divided by r sigma x by sigma y is the slope of this straight line, which means for this equation, regression coefficient myx itself becomes a slope, whereas for this second equation, reciprocal of the regression coefficient becomes the slope. Now, let me note the following before getting into the problems. Note number 1. Regression lines always passes through x bar comma y bar. You can note that if I replace x by x bar and y by y bar in these two equations, we will get 0 is equal to 0. That is, these two equations are satisfied, which means x bar comma y bar is a point on these two lines. In fact, we can claim these two lines intersects at the point x bar comma y bar. Point number 2. We can express myx and mxy in one more form by using this value of r in these two expressions. That is, myx is equal to sigma xy by sigma x square, and mxy is equal to sigma xy by sigma y square. I have just substituted the value of r in these two expressions to write myx and mxy. See, in a problem, if we are interested in regression coefficients and we are not interested in finding the value of r, if that is the case, there is no need to find the value of r to compute myx and mxy. Instead, I can directly make use of these two formulas to compute them. Okay, now let me move to point number 3. In a problem, let me assume regression lines are given, and the question is to find the correlation coefficient. If that is the case, this is what we are supposed to do. If I just multiply myx and mxy, you can easily calculate, right? So coefficient of y, after expressing the given equation in this form, coefficient of y gives regression coefficient of x on y, and this gives regression coefficient of y on x. Once if you know them, you just multiply these two expressions and see what happens. Sigma y by sigma y cancels, sigma x divided by sigma x cancels. We get r square is equal to what? Myx into mxy, which means r is equal to what? Plus or minus square root of myx into mxy, which means by using the given regression lines, you can find the correlation coefficient directly by finding the regression coefficients myx and mxy. Now the question arises, we have plus or minus, which sign should be considered? Because r takes both positive sign and negative sign. Now if I just go back to the expressions of myx and mxy, these are made up of only three constants, r, sigma x and sigma y. You can note that sigma x and sigma y are the standard deviations which are always positive, which means mxy and myx can be negative or positive because of this r. So r, myx, mxy, all the three constants carry same sign. Now if myx and mxy carry positive sign, then r is also positive. If myx and mxy carry negative sign, then r is also negative. Okay, so this is fine. If we just thorough with these 6 points, you can just handle any problem under the heading lines of regression. This is the line used to find best estimation of y for each specified value of x. This is the equation used to find the best estimation of x for each specified value of y. This is called the regression coefficient of x on y. This is called regression coefficient of y on x. And this expression itself, that is the regression coefficient itself, becomes slope of this first equation. Reciprocal of the regression coefficient becomes slope of second equation. Regression lines always passes through x bar comma y bar. You can find myx and mxy by using these two formulas also. And you can find the value of r by using this formula if regression lines are known to us. I hope you people are comfortable with this. Now let me move to problems on them. Have a look at our first problem. Calculate the coefficient of correlation and obtain the lines of regression for the following data, and hence estimate y for x is equal to 6.2. Here first part of the question speaks, or it demands us to calculate the coefficient of correlation, and the formula is sigma xy divided by sigma x into sigma y, where sigma xy is the covariance between x and y and given by this formula. Sigma x and sigma y are the standard deviations found by using the variance formulas sigma x square and sigma y square, where we need to identify the value of n first, and this n is nothing but 9 in this problem, that is the number of values of x or y. And next part is I want capital X and capital Y. Capital X is the deviation of x from x bar and capital Y is the deviation of y from y bar. To calculate this, first I need to know the mean value of x and y. Let me compute them. Now let me tabulate to find capital X, capital Y. Okay, so small x, small y are written. Calculate capital X, that is given by xi minus x bar, square it. Next calculate capital Yi, that is yi minus y bar, square it, and take the product of capital Xi and capital Yi. Okay, next take the sum of xi square, sum of yi square, sum of xi yi. Now by using this 60 of sum of xi square, I can write the variance of x, that is 1 by 9 of 60, that is equal to 6.6667. Now take the square root to have the standard deviation of x. And since sum of y square is also 60, we are expecting the same value for the standard deviation, that is 2.582 for y. Summation xi yi is given by 57 divided by 9, so that gives us this value. Now by using sigma x, sigma y and sigma xy, we can write our r value, that is given by 0.95 in this problem. You can note we have done these kind of problems in our last subtopic, that is under correlation coefficient or under correlation. So right now we are interested in talking about the next part of the question, that is obtain the lines of regression for this data. So line of regression of y on x is given by the formula y minus y bar is equal to regression coefficient myx into x minus x bar. and regression line of x and y is given by x minus x bar is equal to mxy y minus y bar. Let me first calculate myx. It is given by r sigma y by sigma x. Substitute everything in it and the answer is 0.95. Because sigma y and sigma x are same, so this will get cancelled. Myx is directly taking the value of r, that is 0.95. Same thing happens even with mxy. We can substitute them in these two equations. Now the first equation will be in this form. Put it in the form of y is equal to ax plus b. So that is, take 12 to the right hand side and simplify this. So this is what regression line of y on x. This can be used to estimate the value of y. In the same lines, this equation gives x is equal to 0.95y minus 6.4. Yeah, this equation will help us in estimating the best value of x for the specified value of y. Right now, we are interested in talking about or estimating the value of y for x is equal to 6.2. Now make use of this first equation to do this. That is, put x equal to 6.2 in this. That will give us the answer 13.14, which means the value of y at x is equal to 6.2 is 13.14. Okay, here basically what we did, we found the correlation coefficient first, and by using this we found the regression lines. Let me have a look at our next problem. Obtain the lines of regression and hence find the coefficient of correlation for the following data. Okay, first the initial part of the problem runs in the same lines. Let me do that first. N is 10, good. Find the mean value of x, mean value of y, go for the tabulation, find capital X, square it, find capital Y, square it, multiply capital X and capital Y, and take the sum of xi square, sum of yi square, sum of xi yi. Once if it is done, we can find the variance of x. It is 20.4 for this problem. Take the square root to have the standard deviation of x, and similarly find the variance of y, that is 81.8 in this case. Take the square root, that gives the standard deviation of y. Next, find the covariance between x and y. I know summation xi yi, substitute and divide it by 10, that gives 36. Now have a look at the question. The question is demanding us to find the lines of regression first, and by using this data we should compute the coefficient of correlation. For this, first let me compute regression coefficient of y on x, and this formula is employed when we don't know the value of coefficient of correlation. And myx is given by the answer 1.7647, and we can show mxy is equal to sigma xy by sigma y square gives 0.4401. Now let me write the line of regression of y on x. The formula is y minus y bar equal to myx into x minus x bar, and on substitution of x bar, y bar and myx, we get the equation of line y equal to 1.7647x plus 2.6471, and the line of regression of x and y is given by x minus x bar equal to mxy into y minus y bar, and substituting x bar, y bar and mxy in it, we will get x equal to 0.4401y plus 0.3985. These two are the required lines of regressions. This one is used to estimate the value of y, and this one is used to estimate the value of x. Let me proceed further. The question demands us to find the coefficient of correlation. Now to do this, I will make use of regression coefficients and use the formula r is equal to plus or minus square root of myx into mxy. On substituting these two values in this and, simplifying that, you will get plus or minus 0.8813. And we know R takes the sign of myx and mxy. Since myx and mxy both are positive, we are expecting the value of R also positive, and this R is equal to 0.8813. Okay, in this problem, we first found the lines of regression, and hence we found the correlation coefficient by using regression coefficients. But in the previous problem, we first found the correlation coefficient and used it to find the regression lines. This was the small difference that we can notice between these two problems. Okay, now let me move to next problem. In a partially destroyed laboratory record of a correlation data, the following results only are available. Variance of x is 9. Regression equations are 8x minus 10y plus 66 equal to 0 and 40x minus 18y equal to 214. Now we should find the mean values of x and y, the coefficient of correlation, and the standard deviation of y. Let me handle them one by one. First question is find the mean values of x and y. We know that regression lines always passes through x bar comma y bar, which means this x bar comma y bar satisfies these two equations. So now replace x by x bar and y by y bar in these two equations. And on solving these two simultaneous equations or simultaneous system, we will get the answer x bar is equal to 13, y bar is equal to 17. That is, we found the mean values of x and y. Next part is find the coefficient of correlation. To do this, we can calculate regression coefficients from these two equations. Let me assume this equation is regression line of y on x and this one is regression line of x on y. So solve this equation for y and this equation for x. Now regression coefficient of y on x is given by 8 by 10 and that of this equation is given by 18 by 40. Now we can find the value of r by using these two, that is r is equal to plus or minus square root of myx into mxy. Now substitute these two values and on simplification you can note it is equal to plus or minus 0.6. But the sign of r should be positive in this case because mxy and myx both are positive. So r is equal to 0.6. The next part of the question is find the standard deviation of y. To find this one, we can make use of the given, that is variance of x is 9, which means sigma x square is equal to 9, which gives the standard deviation of x, which is 3. Now since I know sigma x, r and myx, I can make use of the formula of myx. That is myx is equal to r sigma y by sigma x to compute the value of sigma y. Substitute everything in it and on simplification your sigma y is given by 4. This is the standard deviation of y. Okay, this problem is different from the previous problems definitely because in this problem table is not given, instead regression lines are given and the variance of x is given. The data is given in a different form and with the available data we found x bar, y bar, coefficient of correlation and the standard deviation. Now let me move to our next problem. compute mean values of x and y and coefficient of correlation of the regression lines. This problem seems to be similar to the previous one, but let me have a look at this. Since regression lines passes through x bar comma y bar, we are expecting this x bar comma y bar satisfying these two equations. Let us replace x by x bar and y by y bar in these two equations and solve this simultaneous system to have x bar equal to -2 and y bar is equal to 1. First part of the question is done. Now to find the coefficient of correlation, let me assume this is a regression line of y on x and this one is regression line of x on y. Okay, with this we can claim this is my myx and this -6 is my mxy. Substituting these two expressions in R, which is equal to plus or minus square root of myx into mxy, we get it is equal to plus or minus 2. But can we accept this answer? No. What is the reason? The value of R should always lies between -1 and +1. So plus and -2 cannot be accepted for the correlation coefficient, which means that, so this is not the answer. Then what is wrong? So the reason may be, I assume this as regression line of y on x and this as regression line of x on y. But there is a chance that this is regression line of x on y and this one is regression line of y on x. Okay, let me do that. Let me solve my first equation for x and second equation for y. And this is my mxy, which is -3/2, and -1/6 is my myx. Use them in R and you can note value of this is given by plus or minus 0.5. This answer is acceptable. Since mxy, myx both are negative, we are expecting the value of R is also negative and we should assume R is equal to -0.5 as my correlation coefficient. What should be noticed here? So by looking at the equation, we cannot decide which equation is regression line of y on x and which equation is regression line of x on y. So once after calculating the value of R, we can come to the conclusion. Let me move to our next problem. Given mean value of x series is 18 and that of y series is 100. Standard deviation of x series is 14 and that of y series is 20. And R is equal to 0.8. Now find the equation of lines of regression and hence find the most probable value of y when x is equal to 70. So this is just similar to my second problem which we discussed. The table was given. Here instead of giving the table, they have given the mean value and the standard deviations directly. Now let me note what and all given. X bar is 18, y bar is 100, sigma x is 14, sigma y is 20 and R is equal to 0.8. Now we can write our regression lines. For that we can compute myx, which is given by 1.14, and we can compute mxy value, that is R sigma x by sigma y. Substitute and on simplification 0.56. Okay, now let me substitute myx in my first equation. Y minus y bar is equal to myx into x minus x bar. We get y is equal to 1.14x plus 79.48. And by substituting mxy in this equation, we get x is equal to 0.56y minus 38. This equation is regression line of y on x. This one is regression line of x on y. This one is used to estimate the value of y and this one is used to estimate the value of x. Now in the problem we are supposed to estimate the value of y, so put x equal to 70 in my first equation and we will get the answer as 159.28. Okay, I hope you people are comfortable with this. The problem is given in different form, but it's quite simple again. Now let me have a look at the next problem. It is different from the previous all problems. Here we are talking about a different thing. That is, we are supposed to show if theta is the acute angle between the lines of regression, then tan theta is equal to 1 minus r square divided by r multiplied to sigma x into sigma y divided by sigma x square plus sigma y square. Further, we need to identify the significance of cases r equal to 0 and r is equal to plus or minus 1. Let me handle this. Suppose if theta is the acute angle between the lines y is equal to m1 x plus b and y equal to m2 x plus c, then tan theta is given by m2 minus m1 divided by 1 plus m1 into m2, where m1 and m2 are slopes of these two straight lines. Now let me write the lines of regressions. That is y minus y bar equal to myx times x minus x bar and x minus x bar equal to mxy into y minus y bar. We know in this equation slope is myx. We have discussed in the beginning itself, slope of this equation is given by what? Myx, and slope of this equation is given by reciprocal of mxy. It is reciprocal of the regression coefficient. Now using these two expressions in equation number 1, we get 1 by mxy minus myx divided by 1 plus myx into 1 by mxy. Now substitute the values of mxy and myx. We get this expression. Here you can note sigma y by sigma x is common from the numerator. In the denominator, this r and r cancels. We will get sigma y square divided by sigma x square. So it is 1 by r minus r times sigma y by sigma x. And in the denominator 1 plus sigma y square by sigma x square. Now take the LCM and simplify. 1 minus r square by r. Here it is sigma x square plus sigma y square divided by sigma x square. Now take the sigma x square to the numerator and 1 sigma x will get cancelled with 1 sigma x here. So that will give us the required answer 1 minus r square by r times sigma x sigma y divided by sigma x square plus sigma y square. Okay, now let me look into the significance of these cases. Case number 1, if my r is equal to 0, in that case tan theta becomes infinity. If that is the case, theta is what? Pi by 2, which means the angle between the two regression lines is what? 90 degrees. They are perpendicular, which means the variables are uncorrelated. That is what it means. When I was talking about the correlation coefficient, I explained you there itself. If the value of r is equal to 0, then the two variables are uncorrelated. Now let me go further. If I take r is equal to plus or minus 1, we get theta equal to 0 or theta is equal to pi, which means the angle between the two lines is 0. What is the meaning of that? The two regression lines coincide, which means we do not have two lines for the given data, then we have a single line, which means that the two variables x and y are perfectly correlated. So this is what I was explaining you people. When you get r is equal to +1 or -1, we claim the data is perfectly correlated linearly, which means we do not have two regression lines there, we have a single regression line. Okay, I hope you people are comfortable with this result, and it's very important from the point of your examination. Let me see a problem on this formula. In a bivariate distribution, sigma x is equal to sigma y, and the angle between regression lines is tan inverse of 3. Find the correlation coefficient. It's very simple. Let me assume theta is the angle between the two regression lines. If that is the case, what is my tan theta? Yes, this is what the formula is, where I know theta is tan inverse of 3, which means tan theta should be equal to 3. That's good. And one more point, sigma x is equal to sigma y is given. By using these two in this expression, we get 3 is equal to 1 minus r square by r. This is sigma x into sigma x, that is sigma x square. Sigma x square plus sigma x square, that gives 2 times sigma x square. On cancellation and through cross multiplication, we get 1 minus r square is equal to 2r into 3, that is 6r. Now take everything to the left hand side. We get r square plus 6r minus 1 equal to 0. It is a quadratic equation in R, and solve it. And the two values are r is equal to 0.1623 r. The value of r is minus 6.1623. Out of these two, we can take only one value, and other value has to be rejected. Which value has to be rejected in this case now? Is this value has to be rejected because the value of r lies outside the boundary. That is, we are expecting mod r is less than or equal to 1, but it is beyond that, so we are supposed to reject this, and the value of r for this problem is given by plus 0.1623. I hope you people are comfortable with this. Please go through the notes. If you have any doubts, please come back, we will discuss. Thank you all.